Greetings everybody, welcome back, episode number 13 of this Clean Architecture course. In this episode, I have decided to talk about domain services. So I hope you've already watched the previous episodes because again, as before, what we discuss in each episode is kind of related to what we have talked about previously. Let's get to this. I've got this, episode number 13, my notes. I've got the project here on my other display. I'm going to navigate to episode number 13. So let's get started. In our previous episodes, we've kind of encapsulated the logic inside of our entities and value objects: department, entity, name, email address, education level, and so on. Now the question is, what happens when a piece of domain logic doesn't quite belong to any one of these? So you've got this like a piece of logic, a method that you cannot decide whether to associate with an employee or a department, for example. So how can you implement such a thing? The answer is domain services. So what is a domain service? A domain service is a stateless class, right, that encapsulates some domain logic. And this domain logic could have these, three characteristics. This domain logic, this piece of logic, this method doesn't fit naturally inside of a single entity or value object. So it means you cannot decide whether you should put this piece of method inside of your entity, domain entity, like for example, inside of your employee entity, department entity. It often involves multiple domain objects or external rules. And then it has some business significance, but doesn't have a clear ownership of data. If these seem to be a little bit ambiguous, no worries, because as we go, as we continue working on the domain model and, study the domain model, the nodes, these will start to make more sense. So think of business domain services like, for example, helpers, right, for your domain logic that need to operate on more than one entity. More often than not, domain services involve, more than one domain entity. And they kind of work on these entities, right? But you cannot decide to, for example, put this single piece of method in, for example, your employee or your department. So why do we need to use domain services? Domain services are helpful because they keep our entities clean and focused. So in your entities, for example, in your department, in your, employee, you need to have the things that are very closely related to that entity. There is this concept called cohesion and coupling that I have talked about, I guess, in one of the other videos I've got here on my channel. So your entities need to be very cohesive. So the operations, the properties that you include inside of like an entity, they need to be closely related. So you need to keep your entities clean. They need to be focused. The properties, the operations, they need to be focused on the core responsibilities of an entity. By introducing domain services, you can promote reuse of domain logic across different parts of the domain model. So more often than not, your domain service is a kind of, it involves an operation that needs to be, repeated. But by centralizing that piece of logic inside of a domain service, you avoid repeating that, right? You avoid that code duplication. Another advantage of using domain services is domain purity. So by avoiding the pollution of business logic with infrastructure or procedural logic, you can, enforce your domain purity. You can keep your domain pure by not letting your domain, get involved with things that are not the direct, let's say, concerns of your domain. Like, for example, communicating with a backend API. So these are domain services. Our scenario. This is one scenario that I have thought about that I want to implement in this, episode. So the scenario is calculating the base salary of an employee. So if you recall, we've got this type called salary, right? And we've got a property inside of the domain entity employee called the salary, right? And if you take a look here, the employee, right? It has this salary property. Now previously, I mean, if I go to branch number 12, previously, whenever we wanted to create an employee, as you can see here, we kind of specify the salary that I want to have for that employee. Now, what I can do is to introduce a service, a domain service, right? To be able to calculate the base salary of an employee based on the education level and the employee role. So the idea is very simple. For example, if an employee has, let's say, a master's degree as the education level, and then, for example, the role of an employee is, let's say, a manager, so probably the salary should be higher than, let's say, an employee who's going to work only as a developer and has, like, for example, a high school diploma. So this is a very simple example, right? So the education level and the role of an employee inside of a department kind of determines the level of salary that we want to set for that employee. So this logic, again, doesn't belong to the employee entity directly. It's not an inherent property, but rather a business rule, right? So it's a perfect candidate for a domain service. Of course, you could, argue that we can introduce, let's say, uh, a method inside of your employee entity to, for example, calculate the salary of an employee based on the education level and employee role. But through implementing this as a service, it would be possible to create different implementations for this service, because we're going to, of course, create an interface, right? And we're going to have multiple implementations of that interface, and that interface is going to be responsible for calculating the salary of an employee. So by creating a domain service, by leveraging interfaces, we can create a loosely coupled relationship between an employee and the service which is responsible for calculating the salary for that employee. And again, we will be able to have multiple implementations of that service to be able to substitute, the employee salary calculator service whenever we want. So let's get to this. We're going to have this base salary calculator, which is inheriting from this interface, or it's implementing this interface. And then we're going to have this, for example, default currency code, right? USD. And then we're going to have this calculate method. This calculate method has a piece of logic. I told you, your domain service encapsulates an important piece of code, right? Important because it is important for your domain model, right? So in my domain model, being able to calculate the salary of an employee based on the education level and employee role, it's a very meaningful, important piece of logic. And I want to implement that as a domain service. So that important logic that I told you is going to reside in this calculate method. So as you can see, I'm taking in the education level, years of experience. It could be like I can let's say refine this, right? I can, for example, take in the role of an employee as well, because in the example that I showed you in Visual Studio, I talked about let's say evaluating the salary of an employee based on the education level and role. But here the implementation is taking the years of experience as well as the education level. This is also very, this is also a feasible, implementation. So I'm having my guard clauses. I'm having my, logic. This is a very specific logic that I have based on my business requirements. I'm not going to go through this. You can pause the video, study this code yourself. And then I'm going to return, after all of these calculations, I'm going to return a new instance of my salary value object with the total and the default currency code, right? So I can show you this, let's say, service. So if I go to episode number 13, right? So I've got this service. I've got this interface, right? And I've got this base salary calculator, right? So the notes, the interface. Now we want to be able to integrate this with the employee. What we are going to do is to update the create method of an employee to take in an instance of this iBase salary calculator and use it to compute or to calculate the initial salary of an employee. And of course, it would be able, we would be able to update the salary of an employee as well. So if I take you to this employee, you can see that here I'm taking in this interface, right? And of course, one thing that you can do is to, write a guard clause against your dependencies. So right now, this create method has a dependency, right, on the salary calculator. So what I have done is that I have created a guard clause and I am guarding against a null reference. And then I am using this, salary calculator, right, to calculate the base salary of an employee. And then whenever I want to create that employee, I'm going to, use that salary, right, that got created here. And then the rest of the code is the same. So let me take you to the notes as well. Again, one thing that I want to talk about here is the SRP, Single Responsibility Principle. By encapsulating that code for calculating the salary of an employee, by encapsulating that inside of a separate type salary calculator, we are again, respecting the SRP principle, single responsibility principle. We are keeping our employee, uh, responsible for its main functionalities. So the responsibility of calculating the salary of an employee is not going to reside directly inside of the entity itself. It's going to be implemented as a service. And of course, what you can do further, the fact that you have implemented this as a service with an interface, chances are in the future you want to create another salary calculator, right, which communicates with a backend API, for example, to kind of calculate, let's say, the base salary of an employee, or I don't know, fetch something from the database first, like for example, the result of the interview that you had with your employee, with your new employee, and based on the, let's say, the correct answers, the number of correct answers they gave to a piece of, let's say, test, for example, you can implement the base salary of an employee, and of course, you would be able to not only update that base salary, but also you would be able to change the implementation of this interface in order to create different, employees with different types of salary. So this is the beauty of this, right? You have your decoupling in place. You are using interfaces, and this allows you to be able to kind of implement as many concrete implementations of this interface as you want in order to, have different methods, have different approaches of creating an employee with a different base salary. So what we did here, the summary, we explained the domain services. We kind of talked about when to use them. We implemented a simple domain service, base salary calculator. And of course, because we're, using interfaces, we've got testability. It is easy to, unit test your service because again, your domain services, because they include some logic, more often than not, you would want to test them, test the correctness of the logic, the method, in this case, the calculate method inside of this base salary calculator. So with interfaces, you can, reach a high level of testability. And then we integrated, that, let's say, service inside of the entity, and we used it inside of the create method to create new employees with the service that is responsible for, let's say, calculating the base salary for that employee. And that's it for this video. I hope you've enjoyed watching this video. If that's the case, as always, don't forget to give it a thumbs up. That motivates me to keep, creating new videos. And Stay tuned for the next episode. Take care. Bye-bye.